All right, good morning, everybody. So today we're going to be talking about a square root, and we're going to be drawing this parent function of a square root. And so, just like all the other parent functions, they have points that they go through all the time. 3 points, right, that we use. -1, 0, and 1 is when we make our table. But if you notice, remember, you're not allowed to take the square root of a negative. And if you're not allowed to take the square root of a negative, notice how this graph has nothing on the negative side, right? There's nothing out there. That's why when we look at what we call the domain, the only x's I'm allowed to use are greater than 0 or equal to 0. That's why the only x's allowed for a square root are positive values, right? So positive values and 0. And then when it comes to the range, well, for the parent function, based on that 0 value, notice how our graph just goes above, because if you're only going to work with positive numbers, well, then it makes sense that you're only going to get positive values and 0 as well. But we're going to do the usual. We are going to translate it. We're going to move it up, down, left, right. We might be doing a vertical stretch and shrink as well, things that we've done in the past. The only great thing about this is every other graph that we've done, we've always worked with the three classic points. So if we look at the table for this graph, so notice how it kind of looks like, if I were to turn it this way, it's like half of a parabola. Think of it that way. Uh, we're looking at our table here, right? This is going to be the table for the parent function. So what we're looking at here is a picture of the parent function. It says y equals the square root of x. So then if I plug in a 0, well, then I get a 0. If I plug in a 1, I get a 1. Those are the 2 points. Notice we're only going to be working with 2 points for this one. It's the only graph we've had to do that for because we're not allowed to work with negatives. Now, if I wanted one more nice little point that works, if you notice, look, there was one more over here, but this one we're not going to worry about too much. But notice how it's not until you get to the number 4. Again, don't forget the square root of 4 is 2. That's why that one works out a little bit nicer. But again, we are only going to concentrate on 2 points to make this a little bit easier. So, just as before, we've talked about how things can move. And so here we have a table of how things can move, especially when you see a parent function like the square root of x. So when we move to the left or to the right, right? So this is a horizontal translation. That only happens if it's inside of parentheses. Well, in this case, there's no parentheses. But what they're saying is if you see it on the inside of the square root, so you got to look at that carefully. We always think opposite. So it says -2. So it says 2 to the right. The other one, of course, says +3 on the inside. And because it's on the inside, then we're going to go to the left. But this is, of course, as always, when we think opposite. So we'll make that little note to ourselves again. So we have to, just as before, with the absolute value, with the square root, with everything we've done, we have to look at where that number is located. So if it's inside the square root, we're going to think opposite. We're going left and right. On the other hand, here, when you have a vertical translation, well, a vertical translation, again, is something from our past. We've worked with those before. In a vertical translation, this is when we move things up and down. That's where the shift happens. But notice where the K value is. It's always outside of the parentheses. Well, in this case, look at where it's located. It is outside of that square root. Same thing with that -1. It is outside the square root. And so just like this one would head down because you do not think opposite here. This one would head up. And just remember, it is outside the square root symbol. Right? That's the idea for this one here. It is outside the square root symbol. Okay. Maybe I should just stretch out these lines here to kind of separate the rule. There you go. Now, this third one, yes, a reflection, and we've done reflections before, except for one. One of them we hadn't seen, and I'm not sure why there's a strike through on this because we will be doing that. So, just could be a typo, something that happened that came up. But a reflection, we can flip, right? That's what a reflection has been on the x-axis, but this time We might be talking about flipping on the y-axis because this one we would have a different look to this graph if we were to flip it on the y. But notice where the negative is, and that's the key, right? If the negative is on the inside, look where the negative is, right there, this is going to be a reflection on the y-axis, which means if you look at the parent function that's up here with the y-axis, we would have a graph here. If I could get a pen that works, we would have a graph that would go this way because it's a reflection on the y-axis. On the other hand, and again, I'm not sure why there's a strike through here. I think that's just a typo. If the negative is in front of the function, so notice where it's located here, you can kind of see it there. The negative is outside, well, then that's when we flip it on the x-axis. And so when the negative is outside, again, ignore the strike through there. Well, for a graph like this, if we're flipping it on the x-axis, well, that's when the graph dips under, right? Comparing everything, of course, to that parent function that's on top. So the y-axis is something we've never had to deal with because if you flip an absolute value on the y-axis, it looks the same. If you flip a parabola on the y-axis, it's still going to look the same. This is the first time where we might see a change. And finally, just like everything else we've done, these are all the moves we've made earlier this last week, right? Earlier in this unit, we could have a vertical stretch or a vertical shrink. The graph stretches away from or shrinks towards the x-axis. And notice it's the a value. It's whatever's in front of the function. So that's why when I see the 4, because it's bigger than 1, which is what we've talked about before, then it's a stretch by a factor of 4. So they're kind of telling you how to describe it as well here. And then, of course, if you have a number in front that is less than 1, then it's going to be a shrink. And all we have to do, remember, we have to do a few things here for these. So we'll make a note of it. So for this one, the a is greater than 1. For this one, the a is between 0 and 1. Because remember, we don't really deal with negatives. If it were negative, that's where this whole reflection takes over. So that's why the negative is something else. When we're looking at the a, it's almost like the absolute value of that a. But just remember, for both of these, I don't care which one, as soon as you see an a value, just like we do here, just like we do here, we multiply the y values or the y coordinates by the a value, whatever the a value is. But it's only the y's, just like we saw before. All right. So again, take a moment to copy these little notes down here. If we need to pause, we can pause, of course. But we're going to get into some examples because we've done all of this last week. We already practiced it. So we're just going to do it again. So here we go. Now, for our examples, that says describe the transformation. Okay, that's what we've done before. And then graph each function. So notice this one is the parent. And then this is the one where they want me to make a few moves. So I know that for the parent, I'm going to go with my classic 0, 0, 1, 1. Because remember, for the square root function, there is only 2 points we're going to worry about. So here comes the parent, 0, 0, 1, 1. So we go like this. There's the parent function. So y equals the square root of x. I call it f of x. That's fine. And now let's talk about the moves they want me to make. So first things first, this negative. So let me write it down here. That negative is telling me to do something. And according to the chart that's on the other side, which you should use, this is going to be a reflection on the x-axis. So we're going to take care of that first. Remember, reflections, we like to do those first just to get an idea of where my new points are going to be. So we will do this first. So here we go. It would still be 0, 0. But remember, because I'm doing the reflection on the x-axis, here's one space away from the x-axis. Well, then I go 2 spaces away. So here's the new point. Remember, still 0, 0. And now it looks like this. So now this is y equals the negative radical x, because all I've done is taking care of that reflection. But now we have two more moves to make, and then we'll be done with this. And with our description, we have a -3 and a +4. But notice where the -3 is located. The -3 is located on the inside. And we've said when it's located on the inside, this is going to be left and right. So we're going to think opposite. So this is actually to the right. And the number 4 is on the outside. So this is up and down. But because it's positive, we're going to go up. But we're going to make it official down here at the bottom. So for the ones that are underlined in green, here's what we're doing. We're going to shift to the right, or we're going to shift right 3 and up 4. So now we're just going to take care of these moves. So look, my description is done. The parent function has been drawn. But now here comes the official final answer for g of x. This was the official parent function f of x. And now I'm going to take these 2 points. Remember, that's a nice thing. It's only 2 points now that we have to worry about. So we're going to take these 2 points and we're going to shift them 3 to the right and 4 up. So here we go. 1, 2, 3. 1, 2, 3, 4. Okay, so now it's here. Don't forget 0, 0 also has to happen. 1, 2, 3. 1, 2, 3, 4. All right, here we go. And yes, it starts from here. Remember, it doesn't go up this way. It starts here and then it heads down like a little half a parabola. So there's my answer. As weird as it looks, and it kind of got in the way for this one, but this is our official g of x. And that's all you draw. Remember, there is no other half if you want to think of it that way. So let's try it again. We have the parent function to begin with. So here's the parent function once again. And they want me to call it f of x. We can call it y equals as well. So here are the classic points, 0, 0, 1, 1. All right, so here we go. 0, 0, 1, 1. So here's the parent function. Remember, it keeps going up, never comes back down. It just slowly goes up. So there's f of x. I'm just going to call it f of x because that's what they called it. And now I'm going to start looking here. And the first thing I notice, I see an a value. It's not a number 1 this time. So because I see an a value and there's no negative, so there's no flipping, right off the bat, I see that this number is greater than 1. So if that number is greater than 1, then for that pink part there, again, I'm just going to color code here for you. Because it's a 2, this is going to be a vertical stretch by a factor of 2. And we're going to take care of this first. This will be the first thing we do. So we're taking care of everything on its own slowly, just like we did before. But remember what this means. When you have a vertical stretch or a shrink, all you're going to do is multiply the y values by that 2. So think of it. It's like we have a whole new set of numbers, right? It's a whole new coordinate. It's 0. Well, it's still 0. 0 times 2 is 0. But then it's 1, 2. So this stretch, look at how it compares with the parent. It's still 0, 0, still there, but it's going 1, 2. And so it's kind of making a high, right? It goes up a little bit higher, and then it just kind of goes out this way. Think of it as some of the games that you've played, like Angry Birds, right? You're kind of always trying to figure out how you're going to shoot that little bird out. Well, look, this is one way. Well, now we're kind of aiming it higher, so it takes this path instead. But there's still one more thing, and notice it's only one more number left, and that's a +2. But again, please look at location. When you look at the location of that point, we realize it's on the inside, so that's left and right, and I'm going to think opposite. So right up here, I'm thinking, all right, I'm going left. So this is going to be a shift left, and I'm only going to go 2 spaces. And so here's my answer coming up here. Again, I forgot to mention this one is y equals, there's the square root of x, there's the parent, but this was just with the 2, nothing else. But now we're going to shift everything to the left too. So 1, 2, there's the new point. 1, 2, there's the new point. And so here goes my graph. Same one I just pretty much drew, but I just moved it to the side. So this is the official g of x function. All right, take a moment to copy there, of course, and just kind of let it sink in for a moment. But that's how we handle these graphs. All right, so that's what you're going to be doing on today's classwork. You're going to be doing that on today's homework as well.